Welcome once again to this YouTube channel. In this video, I'll be introducing organic chemistry based on the IGCSE chemistry syllabus. So under this topic, under this introduction, we'll look at what organic chemistry is all about. We'll look at some terms like the functional group, the homologous series. We'll also look at structural isomerism, we'll look at hydrocarbons, and then we would also look at some of the reactions of alkanes and alkenes, and then we'll solve some topical questions to help you see how all of this knowledge can be applied in solving questions correctly. All right, so let's go in straight. I would encourage you to share videos like this with your friends, okay, so that they can also benefit. All right, so let's go straight to understanding first what is organic chemistry. So organic chemistry is a branch of chemistry, and it's a branch of chemistry that simply involves the study of organic compounds. So majorly in organic chemistry, you're studying organic compounds. Now, what do we mean by organic compounds? Organic compounds are compounds that contain covalently bonded carbon atoms. So organic compounds, you would always see carbon covalently bonded with carbon, carbon covalently bonded with hydrogen, or carbon covalently bonded with any other element. So the focus is simply carbon. But there are exceptions to some of the compounds that we call organic compounds. Not all carbon covalently bonded atoms or compounds are organic compounds. So, for example, carbon dioxide is not an organic compound. Carbon monoxide is not an organic compound. Calcium carbonate is not an organic compound. Okay, so these are not organic compounds. So when we talk about organic compounds, we're talking about carbon covalently bonded with other atoms and the derivatives of carbon hydrogen compounds. So these are not derivatives of carbon hydrogen compounds, and therefore they cannot be regarded as organic compounds. So majorly, we'll look at compounds that contain carbon covalently bonded to carbon, or carbon covalently bonded with other atoms, or carbon hydrogen derivatives. That's what organic compounds simply mean. Now that we understand what we're going to be looking at under organic chemistry, let's see why is organic chemistry important? Why do we have to study organic chemistry? Okay, so organic chemistry is important because the organic compounds we study under organic chemistry are building blocks of many biomolecules that we know, such as proteins, carbohydrates, your DNA, your lipids. So all of these are organic compounds, and there's a need to understand their behaviors, there's a need to understand their structures, and understand several information about them. So the only way we could get to understand all of these things is through the study or through the knowledge of organic chemistry. Now, organic chemistry is equally important because it helps us understand the way drugs interact with the body. It helps us understand some areas in agriculture and also material science. So it's important. It's an area of chemistry or a branch of chemistry that is very interesting. So it's something that could wow your mind if you want to study it in advanced level. So organic chemistry is an interesting area I could recommend you to look at because there are several things you could get from the knowledge of organic chemistry. Apart from that, there is also the aspect of plastics. You want to understand the behaviors of plastics, polymers generally. You get such knowledge from studying organic chemistry. So there are many other applications of this knowledge that would interest you. So all you need to do is to do more research and then you find out. All right, so now that we understand what organic chemistry is all about, let's see the major focus in organic chemistry. So the major focus from the definition of organic chemistry is carbon. Carbon is simply the focus. We're studying carbon. Okay, carbon covalently bonded compounds. All right, carbon-carbon bonded compounds. And then why is carbon so special? Why is carbon so unique? Let's see some of the reasons why carbon is unique. First, we understand that the proton number of carbon is 6, and therefore it has a configuration of 2, 4. So from this information, we know from the periodic table that carbon belongs to group 4 because it has 4 valence electrons, and it belongs to period 2 because we have to fill 2 shells to fill up the protons, number of protons. So 2 shells were filled up, and it belongs to period 2. So there are several other elements in the same group as carbon. For example, silicon belongs to the same group as carbon. But our focus is on carbon, not silicon. I'm going to see reasons why carbon is so special. So the first reason we have here is carbon can form single, double, and triple bonds with other atoms. And that is based on the valence electrons. So look at the electrons in the outermost shell. So it has four valence electrons. So 1, 2, 3, 4. So it means it has four different spaces to bond. All right, it has four spaces to bond. And because of that, it's able to form single bonds. It's able to form double bonds. It's able to form triple bonds. So we could have carbon, carbon single bonds, carbon, carbon double bonds, and also carbon, carbon triple bonds. This shows why carbon is so special. Right, it has a tendency to display these three features of forming single bonds, double bonds, and triple bonds. We're going to see how to display all of this when we begin to draw when we begin to draw display formulas or structural formulas. We'll see more on how to apply all of this knowledge. But the fact remains that carbon is so special. There's four different species to bond, and then it could result in it forming single bonds, double bonds, or carbon-carbon triple bonds. It could also form some of these bonds with other elements such as oxygen, such as nitrogen, or it could form either single, double, or triple bonds with any of these other elements, and that's what makes it really unique. Right. Second reason why carbon is unique is it could, looking at valency, okay, it could link up in chains, very long chains. It could link up in branched structures. It could also link up with rings. So we could have a lot of long carbon chains, carbon-carbon linked chains. Some of them could be branched. Some of them could take the ring form, such as benzene. So there are several dimensions in which these carbon atoms can be arranged, and that's what makes it very unique. The fact that it can arrange itself in different shapes and still be stable. So silicon could also take such shape, but silicon loses its stability as it progresses with the different dimensions. But carbon does not, and that's what makes it really special. Another reason why carbon is special is the ability to bond with other elements such as hydrogen, silicon, nitrogen, and sulfur, and resulting in a variety of organic compounds. So these are very good reasons why we have to study carbon. We have to study why is carbon able to form all of these compounds. And the only way we can do that is to look at organic chemistry. So that is what we'll basically be looking at under this, looking at the behaviors of carbon in terms of forming single, double, and triple bonds, in terms of forming long chains, branch structures, and rings, and in terms of bonding with other elements such as hydrogen, oxygen, nitrogen, sulfur, and any other elements to form a variety of organic compounds. Right. Now we are gradually getting deeper into organic chemistry. We've seen the meaning of organic chemistry. We've looked at why carbon is unique, why we're studying carbon, basically. We've seen the reasons why we have to. And then we'll now go into what we call homologous series. All right, remember this video is basically looking at the IGCSE chemistry syllabus, just points that you need to know, such that when you watch this video, you could go straight to answering past papers and getting excellent results. All right, so under organic chemistry, there are families. There are families in organic chemistry. That is, there are families of organic compounds. Those families are termed, we call those families homologous series. So we use homologous series as a term to refer to the different families of organic compounds we have in organic chemistry. All right, so what is a homologous series? So a homologous series is a group or a family of organic compounds with similar chemical properties, right, and a recurring structural feature. Or we can simply say is a family of organic compounds with similar chemical properties, and each member differ by a CH2 unit. I'm going to talk about how each member differ by CH2 unit. But let's just simply look at it in terms of a family. So when you talk about members of the same family, members of the same family will likely have the same behaviors. So there are certain features that each member of the family should have that identifies them as a member of that family. And that is what the homologous series is all about, telling us that, oh, this is a member of a particular family. And because it's a member of a particular family, they should behave in a certain way. So instead of saying family of organic compounds, we simply use the word homologous series. So it's more like a terminology suited to the context of organic chemistry. All right, so now that we understand what homologous series is all about, that it's simply a word used to classify, used to term the family of organic compounds. And we said they have similar chemical properties because they belong to the same family. All right, now, what are the features of homologous series? That is, how do we know that a particular family should have certain characteristics? What are those characteristics that we are looking out for? So we're going to list them out because this is also a very important question in IGCSE chemistry. You ask us to talk about the features of the homologous series. So number one is what we already stated here. So this is number one. They have similar chemical properties. So members of the same family would have the same chemical properties. That is what we mean by similar chemical properties. So another feature of the homologous series is they have the same general formula. I'm going to talk about general formulas. General formula is simply a formula you can use to generate every member of a particular family. So one feature of homologous series is that for a family, all of the members can be generated using one formula. So that is another feature of homologous series. So they have the same general formula. So that's point number two. Point number three is that they have the same functional group. I'm going to look at what functional group simply means. Functional group is simply an identifier. So it's an identifier of a particular family. So it's simply an atom or a group of atoms that is responsible for the chemical properties of that family. All right. So every member of the same family should have the same functional group because that is their identity. So the chemical properties is linked to the functional group. Okay, so the reason why they have the same chemical properties is because they have the same functional group. That is what I mean by members of the same homologous series should have the same functional group. So that's the third feature of the homologous series. Now let's talk about the fourth one, which I mentioned, that each member differ by a CH2 group or a CH2 unit. Or you could simply say each member differ by a mass of, get the mass of CH2. So the mass of CH2 is simply 12 plus 2, that's 14. So either you say each consecutive member differ by a CH2 unit, or you say that each successive member or each consecutive member differ by a mass of 14. Now, meaning the difference between the second member and the first member is CH2 or a mass of 14. The difference between the third member and the second member is a CH2 or a mass of 14. So that is what it means. Now let's look at an example. This is an example where we have this is a family of alkanes, for example. We're going to look at names of homologous series and all of this information more. But I just want to use this to explain what I mean by each member differ, each successive or consecutive member differ by CH2 or mass of 14. The first member of this family is methane. The second member is ethane. So let's look at whether the difference between two of them, these two members, is a CH2. Just by looking at it, methane has just one carbon. Now, when we go to ethane, it has an additional one carbon. And then if you look at the difference in hydrogen, how many hydrogens are in methane? We have 4 hydrogens here. Let's look at how many hydrogens are in ethane. So 6 hydrogens. You can see a difference in terms of hydrogen is a difference of 2. In terms of carbon, it's a difference of 1. An additional carbon has been used here. So meaning that when you move from the first member to the second member differs from the first member by a CH2 group or a mass of 14. All right, so that's the fourth feature. So this is feature number 4. All right, so let's talk about feature number 5, which is this. There are physical properties. There is a change in physical properties as we progress. So that is what this is simply saying. This is point number 5, feature of the homologous series. That is, as you progress from the first member to the second member, there is a change in physical properties, meaning that as the size is increasing, the melting point or the boiling point increases.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So By my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, um, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the Edexcel. So we have for the Cambridge E levels and Edexcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is what I've discussed with the sales team is we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Ajiro Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
In other words, ethane would have a larger boiling point than methane. Propane would have a larger melting or boiling point than ethane. Butane would have a larger melting or boiling point than propane, ethane, and methane. So that is the point we're trying to make. So these five features are important. So if you're asked a question, list or state the features of, or state the characteristics of homologous series. You could either say they have the similar chemical properties, you could say they have the same functional group, you could say that they have the same general formula, you could say that each successive member differ by a CH2 group or a mass of 14, or you could simply say that there is a change in physical properties as the size increases. So all of these all adds up to give you the mark. I hope we now understand homologous series. All right, so let's go to the next point. Next point talks about functional group, which I already mentioned earlier, that a functional group is simply an atom or group of atoms that determines the chemical properties. So if you look at a member of the family, there is something in them that makes them behave in a similar way. And that thing is called the functional group. That thing is called the functional group. All right, so that is very important in understanding homologous series. So the chemical properties is a function of the functional groups that are present in these compounds. So let's go straight to examples of homologous series, and then we'll look at the general formula of the homologous series, and we look at what functional group identifies them. So the ones you need to pay attention to are the alkanes, alkenes, alcohol, carboxylic acid. So these are the major ones you need to pay attention to according to the syllabus. Now, what do you need to know? You need to know the general formula of these groups. You need to know their functional group as well. So I'm just going to add the functional group beside them. All right, so alkane is an example of a family of organic compounds. There's a family of organic compounds we call alkanes. All right, and the general formula of these alkanes is given as CnH2n plus 2. So this is the general formula of alkanes. So if you want to generate any member of the alkane, this is the formula you're expected to use in generating such member. And n in this case starts from 1. So it moves from 1 all the way to 2, and you go as it's and it continues to increase. So wherever you see n, you replace it with any of the values you are picking. We're going to look at how to generate members, but let's just talk about the homologous series, the general formula, and the functional group. So the functional group of the alkenes is carbon-carbon single bonds. So this is how you identify an alkane. You should always have a carbon-carbon single bond, and this makes it an alkane. So this is alkane. So what you need to know, like I said earlier, is the general formula, know the general formula, know the functional group of the alkanes. So let's go to the second homologous series you are expected to know, the second family you are expected to know. The alkenes is the second one, alkenes. And the general formula of alkenes should also be known. So it's simply CnH2n. CnH2n. Now that's the general formula. And then you also need to know the functional group of the alkenes. The alkenes are simply carbon, double bond, carbon. So this is the functional group of alkenes, while this is the functional group of alkanes. You can see there's a difference. So the way the alkenes behave is different from the way the alkanes will behave because they have different functional groups. The alkenes have carbon-carbon double bonds. The alkanes have carbon-carbon single bonds. The next one we're going to look at is alcohol. So alcohol general formula, I'm just going to write here, alcohol. So the alcohol, their general formula is simply CnH2n plus 1 OH. Right, so this is the general formula of alcohols, and the functional group of alcohols is simply the OH group. So this group is a functional group. This group is responsible for the way these members will behave in terms of their chemical properties. All right, when we begin to look at each of these families, we look at how to draw them, we look at how to generate their members. But for now, we're only going to talk about their general formulas and their functional groups, which is very important. All right, so the next one we'll talk about is carboxylic acid. So carboxylic acid is the next family we're going to look at. Carboxylic acid. And then carboxylic acid, of course, it has a general formula as well. So it's CnH2n plus 1 COOH. So the functional group for this is simply the COOH group. So this is the functional group of the carboxylic acid. So you just ought to note these functional groups, not the general formulas. All right, and you note this, and you're good to go. You could do very well in organic chemistry if you know how to generate the members and you know their functional groups and you know their general formulas as well. So I'm going to add one more group, which is going to be important because when we go into naming, you also need to know these groups. I'll just add it here so that when I mention it again, it's not going to be strange. So there's also a group we call alkyls. There's a family we call the alkyls. And the alkenes is simply an alkane group that is short of hydrogen. It's short of one hydrogen. That is simply what the alkane group is. So it has the general formula CnH2n plus 1. So this is alkyls, and it follows the same pattern as the alkanes, but it is short of one hydrogen. All right, and it has the same functional group because it's just carbon-carbon single bonds. That is one thing about the alkenes. It's still the same functional group with the alkanes. Like I said, there's a lot of similarity between the two. So for IGCSE chemistry, these are the groups you should know: alkanes, alkenes, alcohols, and the carboxylic acid. Know their general formulas, know their functional groups, and you're good to go. All right, so we have seen different homologous series, we've seen their general formulas, and we have seen their functional groups. So let's go into the next concept. We're moving forward gradually. All right, we're moving forward gradually. Okay, we've talked about the characteristics of the homologous series already. All right, in terms of physical properties, we are looking at the melting and boiling points, which are already mentioned. All right, those are physical properties of this. All right, so now that we're moving gradually, we've talked about the homologous series, we've talked about the functional group, we've talked about general formulas, we've talked about how to identify them. All right, so let's go into the concept of hydrocarbons. Now, when we talk about organic chemistry, or we talk about organic compounds, there is also what we call hydrocarbons. Now, hydrocarbons is a very important concept. Hydrocarbons are simply organic compounds made up of hydrogen and carbon atoms only. I'm going to add the word only here because it's missing here. This shows that this only is very important. You cannot define hydrocarbons without stating the word only. That is, when you talk about hydrocarbons, you're only going to find hydrogen and carbon atoms only, nothing else. No other element is there apart from carbon and hydrogen. So when you are asked to define hydrocarbons, you have to state the fact that they are organic compounds that contain carbon and hydrogen atoms only. The word only is very important. Emphasis on the word only. It has to be there for you to have the full mark when you're giving the definition of hydrocarbons. Now, what are the sources of this hydrocarbon? We're going to talk about this when we go into um, crude oil, but I just want to give a quick introduction to the hydrocarbons. Their sources are majorly crude oil, like petroleum, natural gas, and coal. All right, so all of these are fossil fuels. Okay, these are the sources of fossil fuels or the components of fossil fuels: petroleum, natural gas, and coal. That is where you majorly get hydrocarbons. So these hydrocarbons are classified into two important ones according to the syllabus. All right. Of course, there could be three, but the syllabus wants you to stick to these two. So the two classes of these hydrocarbons are saturated hydrocarbons, and then we have the unsaturated hydrocarbons. All right. So what do we mean by saturated hydrocarbons? Saturated hydrocarbons are simply hydrocarbons that have carbon single bonds only. All right. So when we talk about saturated hydrocarbons, we are looking at hydrocarbons or organic compounds that contains carbon single bonds only. So that's the definition. They contain carbon single bonds only, and that's what makes them saturated uh, hydrocarbons. Then the opposite, which is unsaturated hydrocarbons, these ones have carbon double bond, or they could have carbon triple bonds. So when you have the hydrocarbon that contains carbon double bond or carbon triple bonds, we simply refer to them as unsaturated. All right, so this is a very important definition. Saturated hydrocarbons, they contain carbon single bonds. The unsaturated hydrocarbons contain carbon double bonds or carbon triple bonds. So basically, we can confidently say that saturated hydrocarbons are alkanes, all right, while unsaturated hydrocarbons are alkenes. All right, for the syllabus, we could also mention alkynes, but for the syllabus, you're not expected to talk much about alkynes. Okay, you're expected to focus on only the alkanes and the alkenes as far as this is concerned. So these are the differences between the saturated hydrocarbons and the unsaturated ones. So saturated ones contain carbon single bond. The unsaturated ones contain carbon double bonds or carbon triple bonds. Or you could say they do not contain carbon single bonds as a definition. All right, I'm going to talk about aromatic compounds because it is not in the syllabus. Okay, so aromatic compounds is also a different dimension or a different class of hydrocarbons. All right, so now that we know what hydrocarbons are, we know the two classes of the hydrocarbons based on what the syllabus wants you to know. Let's now go into how do you identify any of them. That is, if you have a saturated hydrocarbon in a container and you have an unsaturated hydrocarbon in another container, how do you differentiate? What tests can you do to identify either of them. All right, so let's go into this is just a further explanation of what I mentioned in the previous slide. So this is a test for saturated and unsaturated hydrocarbons. This test is extremely important. You need to know this test. So the name of the test is called bromine water test, or we could say aqueous bromine test, or whatever name you want to call it. Bromine water test is the name of the test. This is the name of the test. Okay, and bromine water has an orange color. Okay, so we're going to test each of these compounds, whether saturated or unsaturated, with this bromine water. So what we have here is the chemical sample you're trying to test is here. Okay, all you need to do is to add 3 drops of bromine water. All right, so when you add drops of bromine water into a saturated hydrocarbon, remember saturated hydrocarbons, they contain carbon-carbon single bond. By the time you add bromine water, or by the time you add the saturated hydrocarbon into bromine water, you see that the color stays orange. That is, the color of the bromine water does not change. It stays orange. But by the time you conduct the same test for an unsaturated hydrocarbon, that is, any compound containing carbon-carbon double bond, or a compound containing carbon-carbon triple bond, you would observe that the bromine water would decolorize. That is, it's going to become colorless. So in simple terms, bromine water is the name of the test, like we said. If you test it with a saturated hydrocarbon, the color stays the same. That is, the orange color stays. But when you test it with an unsaturated hydrocarbon, it's going to decolorize it. So it's going to move from orange to colorless. So this is how to identify whether that sample you are testing is a saturated hydrocarbon or is an unsaturated hydrocarbon. And that's just a simple test and the only test approved by the syllabus. So you need to know this test. That is very simple. It's just a bromine water test. And then you talk about the observations. With saturated hydrocarbon, the color stays the same with bromine water. But with unsaturated hydrocarbon, the color changes from orange to colorless. Or you could say it gets decolorized. That is, the bromine water gets decolorized. All right, so you can see that we are moving gradually. We've talked about homologous series, we've talked about organic chemistry, we've talked about hydrocarbons. We're now talking about the classes and how to test for them because it is important according to the syllabus that you know all of this information. All right, so I'm going to move to the next concept, which is to look at some formulas that you're going to come across as far as this topic is concerned. So I'm just going to identify some of the formulas you're going to be seeing, and then we'll just talk briefly about them. So first, let's look at some formulas or some representations of this organic compound. There's the first one, we have the empirical formula. So the empirical formula definition is important. So the empirical formula simply, it tells you about, it's a formula that shows the simplest whole number ratio of the atoms or of the atoms in that compound. So it shows you the simplest whole number ratio, okay, of the atoms in the molecule of the compound. So I'm just going to write it briefly, okay, just to save time, okay. So the empirical formula is something you should know, okay. It's a formula that will show you the simplest whole number ratio of the atoms in the molecule of the compound. Now, there's also what we call the molecular formula. Molecular formula, right? So molecular formula kind of shows you the actual number of atoms in the molecule of the compound. So this one shows you the actual, while empirical shows you the simplest. Okay, so you need to know the difference between an empirical formula and a molecular formula. We're going to do something to test for all of them, so you know how to differentiate them. And then apart from knowing what the molecular formula is about, you also have to know what we call displayed formula. You could be asked to draw a displayed formula. So a displayed formula will simply show you this shows the spatial arrangement, shows the spatial arrangement of all the atoms in the organic structure. So it shows you spatial arrangement of the atoms. So just like you want to show the kind of bonds that are there, Display formula will show you the kind of bonds. It will also show you how they are all spaced, how all the atoms are spaced. All right, I want to do something to help you understand all of this. So I just want to write out the formulas you could be asked to work on. And then the last one is structural formula. Okay, so structural formula simply shows you how each of the atoms are linked to one after the other. That if you take each group that are linked up and then you show how they are all arranged. So that is what structural formula is all about. Okay, so now that I've introduced you to the four formulas, so that you are not so that when we talk about drawing of these structures, you are able to identify these formulas. That's the essence of running through these formulas. All right, so now that we understand, we have seen structural formulas, let's now go into, let's go back to the slide and talk about what structural isomers are about. All right, so structural isomers are simply organic compounds with the same molecular formula but different structural formula. All right, so that is the definition. Structural isomers are organic compounds with the same molecular formula but different structural formulas. That is, you're going to have two organic compounds having the same molecular formula. What do we say a molecular formula is all about? It's all about the actual number of atoms. So you're going to have two compounds with the same number of atoms, the same number of actual atoms there, but the way they are displayed would be different. And that is what structural isomers are about. So we're going to be learning how to draw different structural isomers when we go into uh, each of these homologous series. All right, so we're going to dive in straight to each of the homologous series now. We're going to apply structural isomers. We're equally going to apply um, the different formulas that we mentioned. That is the empirical formula, the molecular formula, the displayed formula, and the structural formula. So we're going to apply all of this in each of the homologous series that we discussed. All right, so we're going to begin with the first group. That's the first homologous series, which is the alkanes, in the next video. So please continue to watch this video, share with your friends so that you can follow all through and get a proper understanding of what each of these formulas, and we talk about the homologous series, how they relate to all of these formulas.